Listen, to those of you who have joined us, welcome. My name is Marcus Bussman. I'm the chair and a professor in mechanical and industrial engineering. And it's a real privilege to welcome you to this MIE Research Spotlight event and to introduce our speaker, Professor Amy Bilton. I'll say a little more about Amy in just a minute. I've been asked to remind you or to tell you that we're recording this session. Now, you're not appearing on the screen, so that shouldn't be a big deal, but I do want to say that we welcome questions. So I'm going to ask Amy in a minute to start presenting, and she's going to present for, on the order of 35, 40 minutes, something like that. And then we want to leave some time for questions at the end. And so if you look down at the bottom of your screen, you'll see a little Q&A button. Anytime in this hour that you have a question that you'd like to ask of Amy, type it into the Q&A. And then when Amy is done her presentation, then I will come back and moderate a few of those questions and provide you some answers. So the other thing I wanted to mention is before we get too far is that after this event at 1 p.m. we've set up a little separate networking event to allow us to meet each other. And so we'll provide more information on that towards 1 o'clock. That'll be in a different application than Zoom. And so we'll explain that when we get there. So it's a real privilege to introduce Professor Amy Bilton to you. So a little bit about Amy. Amy is an Eng-Sci or engineering science grad at the University of Toronto from a few years ago. She has worked in the aerospace industry a little bit, went to MIT in Boston to do a master's and PhD degrees, and then was hired back into our department of MIE a few years ago. She does research around energy and water use and is the director of her own water and energy research lab. And also pertinent to this presentation, she, within a couple of years of joining MIE, became very involved with our faculty-wide Center for Global Engineering, or CGEN, and now leads CGEN as director. And so I think in this presentation that she's going to provide you, she's going to talk a lot about her own research, but I think she's also going to touch on the work that CGEN does more broadly within the Faculty of Applied Science and Engineering. And so to all of you who have joined us, faculty, staff, students, and alumni, welcome. And I will now hand it over to Amy to take it over.
Yeah, thanks a lot, Marcus. As Marcus mentioned, I'm gonna talk a little bit, focus on a few projects first that are within this area of water, energy, and global development that we've been doing in my own research group. And then I'm going to talk a little bit more broadly how this fits in with some of the things that we're thinking about more broadly at the faculty. So in my own research group, I think about water and energy systems. And a lot of the applications that we're thinking about are technologies geared towards the base of the income period, so pyramid. So you may have seen an image like this before. The idea here is this looking at different tiers of income. Most of the people who are on this webinar today are going to be up here in the top of the pyramid, which would be considered, the top 10% in terms of income earners. In this work that we're doing and some of the research that we're doing more broadly in CGEN, we're thinking about the base of this pyramid. We're talking about the poor and very poor. We're talking about people that live on dollars per day. Part of the challenge as a designer is a lot of the people who are doing the design work are in the top of this pyramid, and a lot of them are doing design work really geared towards the top of the pyramid. So a lot of times the people at the base of this pyramid, and there's a lot of people, are getting left behind. They pay the highest prices relative to their income for products, and they're not really geared to be able to satisfy the needs that they have. So in my own research group, we think about how can we really understand some of these challenges, and how can we, think about technologies which are really going to enable the growth of that base of the pyramid. You may be familiar, this is just a picture of an engineering design process. And as a result of kind of how design is done, there's a lot of technologies when they're really designed for the base of the pyramid, they're not really applied and developed in the appropriate context. So often as a result, technologies which are designed for the developing world often miss some of the key requirements. They don't really understand what the full problem is. And even sometimes technology which is really thinks about and is able to really clearly define all the requirements fails to make an impact. So we're going to talk a little bit about some of the things that we're doing in my group to think about this engineering design process, think about different parts in this engineering design process, and talk about some technologies which are fitting into this space of water and energy and global development. So there's lots of cases where in this engineering design process, things tend to come up short. And I'm highlighting a couple examples. We're going to talk about some water and sanitation examples as I go through the seminar today. So let's look at a couple examples where things tend to come up short. Many people in the developing world, 2 billion people, lack access to basic sanitation. They'll either be relying on something called pit latrines or a pour flush toilet, which is what I'm showing in this picture here, which is basically the standard toilet you may have. And instead of having there's not hooked up to piped water, they'll just pour water in to flush it. And this is despite the fact that there are many sanitation systems on the market, really, which were geared to being appropriate for these type of applications. Other examples where technology and innovation, there is stuff out there, it just has come up short in this context, is a classic example of hand pumps. There are over 60,000 hand pumps which are installed in sub-Saharan Africa every year, but up to 66% of them fall in disrepair. This is partially because it's not really thought of, how this technology is going to integrate into this context, and there's really key things that are being missed in the actual context of putting these types of things together. There's many different classic examples. I'm going to highlight one more before we talk about some of the things that I'm doing in my research group. This is a case study you may have heard of before. It's called the Playpump. So the idea really came up in the late 1980s. It was first presented at an agricultural fair, and it's shown here. The idea is, in many of these locations, they need to have water needs to be able to pump and people will come to a central collection point to collect water and bring it to their homes. Why not think about giving some equipment for children to play on, and then be able to use some of that energy from the children playing to actually pump the water. So that was the idea. And you can see it here. The idea is that you would have children, there'd be play equipment like a merry-go-round. The children would be able to go use that and be able to pump the water, and then it would pump it up into a water tower. And then later on, when water was needed, it could be collected. So this garnered a lot of attention. They got millions of dollars of investment from organizations like the Clinton Foundation, other big donors. But in many cases, it's actually seen as a big failure. There's many things about this particular technology which really were missed when thinking about that design process that really led it to something be something which didn't satisfy the needs that it was intending. There were things from a technical perspective. In the design of the Playpump itself, the amount of energy that would be needed to be able to pump that water was really great. There's no way that in a community where kids might play for half an hour a day, they're not going to get enough energy to pump the water up there. There's actually studies done on this that showed you'd have to pump the water for kids would need to play for more than 24 hours a day to be able to get the adequate water for a particular community. So there were technical issues even from the get-go. But there are also big social and cultural failings in the design of this as well. The fact is, when they actually went and installed these play pumps, they also installed them in locations where there were already boreholes, because putting a borehole and installing a pump is really an expensive endeavor. So they actually installed it over where there might have been working pumps. So as a result, now if I'm a woman in the community, and it's usually women who are going to collect the water, if I arrive at the site and there's no water ready for me to pick up, I'm going to have to turn around a little merry-go-round to get the water that I need to be able to supply water for my family, which is really a degrading experience. There were also maintainability issues. So this is a case where there was a lot of things that went wrong in the design process and in the actual implementation that led to something which really wasn't satisfying the needs of the community. So really, what can be done? We need to be really careful when we're thinking about the design process, when we're thinking about these types of technologies. We think about these types of technologies in my research group, and what we do is as we go through the process, we end up working with partners, and these are usually NGO partners, which are working with communities for 10, 15, sometimes more years, and have integration with those end users to be able to really understand that we're addressing an appropriate need. And then working together with those partners throughout the process. And then another thing that we do when we're thinking about technology, and we'll see this in a couple of examples that I'm going to talk about, is that we really try to boil down to the fundamentals when we're going through the process. So instead of just taking something which was developed for a developed world context and apply it in the context of global development, we really try to understand what the barriers there are and then think about how we can address it from a really fundamental way. So I'm going to walk through a few examples of things that we've been doing in my research group. And then we do a broad range of things in my research group, from developing, actually working towards developing some materials which can improve water treatment, to thinking more about more applied technologies towards agriculture, aquaculture. So I'm going to talk more about the applied technologies today, but if you want to chat more about some of the more fundamental materials kind of stuff that we're doing, I'm happy to chat more about it in the networking afterwards. So I'm going to focus in on the application, some of these applications, sustainable sanitation, some of it's early work still, but some our approach when we're thinking about these aspects, and some of our work that we've been doing around aquaculture and agriculture. So one of the things that we want to make sure that we're doing, and really when we're thinking about this process, is really trying to understand really what the problem is before thinking about what can be done. So we're looking at this in the context of sanitation right now. So we have a couple different NGO partners which have been working on interventions related to sanitation, installing dry toilets and other different biogas-based toilets to locations where what they had before is one of these pour flush toilets. So there's a lot of these types of technologies already available on the market. So we really wanted to understand, and this NGO really wanted to understand how the users are interfacing with this technology and really understand what are the gaps. So like why is it that that a user will default to this type of technology rather than implement a more sustainable type of technology for sanitation? So we wanted to really understand some of these gaps because there are so many technologies out there on the market. And so we're working together with some partners to do that. So part of the keys when thinking about this is working and understanding with the end users really what are the challenges there. We can use census data and we can use surveys. Census data is usually outdated. Surveys, you can understand a lot from doing it, surveys and focus groups and those types of things. But we really want to be able to get more quantitative data. And if you're trying to get some quantitative data from end users, when you're thinking about self-reporting, there's often a lot of challenges there. So really we wanted to think about, was there something that we could do to be able to understand how the users are interacting with their sanitation technologies? So the idea was, and we can't, usually if you want to get this type of quantitative data in certain contexts, what you can do is you can sit there and you can watch a user interacting with their technology. You can watch how it's used, you can take notes, you can really get that kind of quantitative information. But with sanitation, you can't watch someone using the toilet. So the idea here is to be able to put some embedded sensing, which is really unobtrusive, and be able to understand really what are the key aspects when you're thinking about some of those more advanced technologies, which our partners are currently implementing for sanitation, and some of the more basic technologies which the end users are defaulting to, really understanding how the complexities of how they're being used. So this is a project which is currently ongoing. Some of the aspects of it have been delayed, but our partners are currently continuing with their work in the field. So we're actually using a mixed methods approach, where we actually do the focus with our partners, do focus groups and surveys to understand what are some of the challenges which the users are experiencing with relation to sanitation, in addition to be able to gather some of that quantitative data. So here's a picture of a small sensor unit about the size of a deck of cards, which can enable us to understand how the toilet is actually being used by the end users for both some of the more advanced technologies and the more traditional pour flush toilet, which the end users are currently is really pervasive in many of these global development contexts. We're currently going through a process of gathering this data. And then the idea is, and this is to be able to really understand, hopefully try to understand really fully what the problem is, and then think about, together with our NGO partners, about what approach can be taken when we're thinking about implementation of interventions related to sanitation in their context. So let's just hit a quick example of when the initial parts of the design process, you really want to be able to fully understand what's going on before proceeding forward to think about how you can design something to address some of those challenges. I'm going to focus in on a couple other things that we've been doing, which are more advanced along this design process. I'm going to focus on some applications that we've been working on related to aquaculture. So aquaculture, or fish farming, is something that's actually a growing food source. It's actually the largest, the fastest growing food source in the world. And it's not something that I knew a whole lot about before I did a work term down in Australia, in between my postdoc and starting at U of T. But that's when I realized how influential this area was. There's 18 million people in Southeast Asia which rely on aquaculture as their main source of income. A lot of the people who are doing the fish farming or this aquaculture activities in Southeast Asia are small fish farmers. They'll have ponds which are dug on their properties. This is an example of a small one, but it's an example of what some of these ponds look like. One of the challenges for these types of farmers, as I was going and doing some interaction with these farmers and different partners, I realized one of their challenges is really related to water quality. So big fish farmers in a developed world context will use these types of large mechanical aeration devices that help introduce oxygen, improve water quality, and improve the amount of fish they can grow. However, this is not something which really is accessible for many of these types of fish farmers because they don't have really access to reliable infrastructure and the resources which they need to do this. So we wanted to see, as someone who does stuff related to water and energy, I saw this problem and I saw this might be a place which we would be able to contribute. So from an engineering design process part, we wanted to really first define the problem. So we did some work with the end users, really understanding what the demands of this type of application are. We also started from a fundamental standpoint, really trying to boil down and understand what's going on from a physics perspective. What's really going on in these fish ponds? And is there something which could be influential, thinking about dissolved oxygen for these fish farms, which would be an accessible technology? So what we did is we looked at what happens in these fish ponds. So this is a cross section of one of these fish ponds. What you'll have is you'll tend to have high levels of dissolved oxygen at the top. And that's because the source of dissolved oxygen is often from algae interacting with sunlight, photosynthesis generates oxygen. So you get lots in the top of the pond, but you get very, very little in the bottom. So most of the fish will live at the top of the pond. What an aeration technology does is a couple different things. But in the end, it ends up mixing this water column and enables it so the fish has this larger range of places they can actually reside in the pond. So, and more dissolved oxygen overall in the pond. So we wanted to think about, we wanted to think about the way that we could do this to be able to help farmers have healthier fish and higher yields, and as a result, higher incomes for these smallholder fish farmers. But would be able to get around some of the barriers of existing technologies, mainly the fact that they're expensive and they require electricity, which results in operating costs and also are challenging from an infrastructure perspective for many of these farmers. So we wanted to see, could something simpler work? So we started at a very fundamental level. So we started by doing some very basic modeling of what was going on in the pond. And we started with some very basic models for the first stage. We actually took the pond, we divided it into different control volumes, top to bottom, to try to see if something simpler might work. We modeled what happened in these ponds when we didn't have any aeration at all. And we saw that, our model actually reflected reality pretty well. And then we saw what happened when we actually just did something very simple, where we actually could circulate water between the top and bottom of one of these ponds. And when we did that, we saw we could actually really improve the dissolved oxygen levels across the depth of the pond. So this really lent us to be, so circulating is something that's a lot easier, could be potentially a lot easier than some of these more intensive aeration devices which are currently on the market, and something which maybe we could make an accessible technology for many of these types of smallholder fish farmers. So we've been working on a couple different concepts in the lab to really do this. And I'm just going to show from a high level perspective 2 of these technologies. So we have one here on the left. This is the idea here is it's actually a vertical axis wind turbine. So it functions pretty similar to what you might expect. So you have wind which would turn this turbine. And then it's connected below the water with an impeller. And then this impeller enables a circulation of the water in the pond top to bottom. Something that's actually fairly simple to set up but has some moving parts. So there is some complexity here. Another technology that we've been working on and evaluating is a solar powered version of the device that actually doesn't have any physical moving parts. So the idea behind this is that you have this structure here, which is floating in the water, painted black. So sunlight could be incident on this, and it's a hollow cavity, much like a boat floating in the water. Sunlight would be incident on this surface, painted black, and heat up. Then it would heat up the water on the backside of the surface floating in the water, and then cause convection. And then to help make sure that we get really full water circulation throughout the pond, we have this draft tube which channels water from the bottom of the pond and enables this full kind of circulation top to bottom in the pond. So these were 2 concepts we had under development. We've actually gone through a process of evaluating some of these technologies with partners in Bangladesh. This is a picture actually of a very first simple prototype we put together of the wind-based technology. And some sample data here on the right. So the top here is showing the wind speed over a 4-day period, which is relatively low wind speed. We're talking between 1 and maximum 4 meters per second. But even with this relatively low wind speed, we're able to get a really big impact on what the dissolved oxygen levels could be at the bottom of the pond, and actually a 60% increase over a baseline value. And so we've been actually working through a process, and we actually have done an extensive field study on the solar and are working towards one on the wind. It's been held up a little bit because some of the challenges that are currently going on with COVID, to be able to really evaluate these technologies together with partners in Bangladesh. So here's a picture of some of our research staff, which we had working with us in Bangladesh on testing of this technology, in collaboration with BRAC and WorldFish. So these activities, unfortunately, are a little bit on hold right now because of everything that's going on in the world, but we're excited about understanding really what the impacts can be more fully on fish farmer production and income related to these types of technologies. So this is, and then I've had a few students that have also been looking at taking this technology and translating it out from the lab. There's a couple different mechanisms that they've been looking at being able to leverage to do that. This is a picture from just over a year ago. Again, some of the activities are a little bit on hold because of some of the challenges going on right now. But we've been able to secure some significant funding to look at taking this technology and extending it out to some commercial opportunities. So that gives just an overview of some of the things that we've been doing related to aquaculture. I'm going to talk about one more project that we've been working on in my research group, which is focused on efficient water usage for agriculture. So the idea here is, thinking about farming and agriculture. A lot of farmers in a lot of places in the world will require irrigation of their land to be able to be productive. How this is done in a lot of places in the developing world is through a method that you're seeing here. There'll be these canals put into different fields, and that these will be flooded at different points of the day to be able to provide water for the crops. This tends to be really water inefficient. There's lots of water that's lost along the way. It's evaporated. There's been a lot of people thinking about implementation of technology to make the water usage more efficient for a lot of these farmers. So one way that people have been looking at is drip irrigation systems. So the idea is that you would have, instead of these open channels, you have tubing that's running through your field. There's small holes by the base of the plants to emit water, and it enables a lot more efficient distribution of water. Some of our partners have been working together with some farmers and to enable financing for farmers to set up these type of drip irrigation systems. So we've actually been working with an NGO in Nicaragua that's been doing this. And it's a simple gravity-based system. There'll be an elevated tank, then the piping running through the field connected up to some of these drip lines. But we were going through and working with our partner in the field in Nicaragua and doing some interviews from the farmers in terms of their experience working with the systems. And some of the things that they really noted was, although this is enabling a lot more efficient usage of water for irrigation for them, there was still a lot of challenges they were dealing with. They didn't know necessarily how much they should be watering their crops, when they should be turning the irrigation on and off. And they were just really mostly doing this in an ad hoc way, where they'll just turn it on for X number of hours per day and turning it back off, but not really having a good feeling for how much they should be watering their crops. So this led us to think about, is there some technologies which would be appropriate, which would help enable these farmers to be able to use their water in these types of drip irrigation systems more efficiently. So again, we followed a process that we tend to follow in our lab. We started by just boiling it down to the fundamentals of what's going on. So it turns out when water is into a field, into soil, it's a porous media. There actually is a property called soil water potential. So depending on the amount of water in the soil, there's a certain amount of force which the soil will exert on the water, drawing water down into the porous nature of the soil itself. So that's it's called the soil water potential. So, and what that potential is depends on the amount of water which is in the soil. So if there's very little water in the soil, there's the soil water potential will be able to exert a pressure which is less than negative 15,000 kPa. Where it's about the point where most plants would like to grow, it's able to exert a pressure of around negative 30 kPa. And then if the soil is completely saturated, the water is not going to penetrate down to the soil, it's going to puddle on top. And it would have a soil water potential of 0 kPa. So we thought to ourselves, so this kind of force is what a plant needs to act against when it's drawing water out of the soil up into its leaves to be able to grow. So plants want to be operating somewhere around this point, and it depends on the plant. But so we thought to ourselves, is there some way we can exploit this type of physics to be able to think about something which is going to be accessible for these types of smallholder farmers to think about irrigation? So it turns out that we can. So we thought about how we could set this up and put together this type of technology. And I'll talk a little bit more about how it works in a moment. We set up some design constraints in terms of what we wanted to do. The idea was that it was something which we wouldn't need to have electricity to be able to have. You wouldn't need any really very little tools and expertise to set up. You wouldn't necessarily need irrigation experience, and it would be something which would work with a gravity-fed drip irrigation system. So we came up with the concept which is shown on the right, and I'm just going to walk through just very conceptual. Some of the aspects in terms of how it's set up has changed since this image, but it gives the concept of how the technology works. So the idea here is we have a ceramic tip which is buried in the soil. So this has similar properties to the porous media of the soil. So it's able to get in good contact with the soil and be able to really be in pressure equilibrium with the soil. So we take this ceramic tip buried in the soil, and then we have a water column. And on the other side of this, on the one side of this water column, we have this rubber membrane connected up to a piston, which then operates a valve between an inlet and an outlet into a drip irrigation network. So the idea is when the soil is dry, it creates that negative pressure and it pulls back on that membrane. It opens up this valve and it enables water to flow from the drip irrigation, through the drip irrigation system. Then once the soil is moistened, and you could design this so it would be in equilibrium when the plants would, that happy operating plant for the plants. So once the soil is moistened, then the pressure would equalize, and then the valve would close up again. So the idea here is that you could have a very passive mechanism to be able to regulate the water flow into this drip irrigation network. So this is the concept. We worked through some we went through, and once we developed the concept, we did a range of different focus groups with some of the end users, with our partners in Nicaragua. They were able to actually very easily put together one of these prototypes and concepts, and really be able to also we found also in our focus groups that they were able to understand the very basic aspects of the technology, and there would be something that they'd be very interested in adopting. And since then, we've been working on more fully kind of developing and fleshing out any issues with the actual technology itself. This was something that we were hoping to be able to do some more comprehensive testing on in the summertime with some of our partners, but unfortunately, because again of the COVID situation, we weren't able to get out as much to the field as we would have liked. But here's some sample results that we have from a very simple setup for the system, which shows the basic concepts of the operation. So you can see here, this is the pressure, which would be in this related to the soil water potential. So you can see the soil water potential here dropping down. And once it reaches a certain point, the water flow will start flowing through the drip irrigation network. And then the pressure will increase, the valve will close up again, similarly drop back down. So we're able to do this type of regulation of water flow through a drip irrigation network. So we're in the process right now of planning on some larger scale. That was a very simple test, which we were able to do in a greenhouse. We're planning right now towards some larger scale applications of the drip irrigation controller. Again, some of my students are interested in thinking about commercialization of the technology. So this is just this past summer, they entered a competition, which is through the American Society of Mechanical Engineering. They have something called the iShow, which is geared towards technology, which can make a social impact. And they entered the technology there, and they were one of the winners. So we're able to secure approximately about $10,000 US to think about some more development of this technology, and have been going after some more funding to be able to take it to the next level as well. On the lab side, we're planning towards, at least right now, we're doing most of our plans locally just because of some of the restrictions going on in place. Where we planned for a larger scale test next summer, hopefully with the Courtright Center for Conservation here in Toronto, where we'll set up a larger plot with this drip irrigation. And we've done some very basic calculations in terms of what might be saved. Right now, up at Courtright, the farmer who's operating this drip irrigation system is using just a very simple timed irrigation. And we did some calculations based on some of the weather data that we could save about 75% of the water over some very simple timed irrigation with these types of controllers. So it's something which has a lot of potential, and a potential to also be an accessible technology for many of these smallholder farmers. So that's just a quick overview of some of the technologies and some of the things that we've been doing in my research group. We're really, in my research group, thinking about this engineering design process, trying to understand where are some of the key things that are being missed and how we can develop some technologies which can really meet the needs of our end users. And really, all this starts for us from really a fundamental and collaborative approach to this kind of development. Just before I wrap up today, I want to just make a little note that these are some projects which are going on within my own research group, but I'm not the only one at the university doing these types of projects which are geared towards making an impact in global development. So as Marcus noted at the beginning of the talk, I'm the director of the Center for Global Engineering, which is a cross-disciplinary institute within engineering, which has over 30 collaborating members. It's been around since 2009, and really the mission is to try to educate the future leaders at University of Toronto in engineering and practice and in research with a commitment towards improving quality of life of the world's most vulnerable people. And we do this through research, courses, and other activities. So there's a number of courses that we teach, and we've also been working with some of our NGO partners. I talked about some of them that we were doing some research with, but there's also NGO partners that we work with that enable students to do some design in this context as well. There's a range of them, from some of our partners I was mentioning in Nicaragua, to World Vision in Cambodia, to different social enterprises also in the Philippines and elsewhere. And then we have a number of research initiatives and themes that we've been working on within CGEN. These are some of our initial kind of research pillars in water sanitation, food, shelter, and diagnostics. And there's been a lot of really influential projects within this area. One of the bigger ones is a project which is being led by Yuling Chen, funded by the Gates Foundation, looking about really reinventing the toilet. Other types of projects which are really impactful, which have been going on in the center. This is just a headline from some work which was done by Professor Levente Diosati from chemical engineering. And these types of projects which are focused on global development have a wide range, and this really demonstrates that. I was talking about some related to agriculture and aquaculture. Levente's work is thinking about how we can get nutrients most effectively to people, and he developed a process that enables embedding of iron into salt. And in studies, they started by doing some studies on how effective this was, and it found it was like very effective in terms of alleviating anemia. And now this is in certain populations where the diet tends to be very low in iron. This double fortified salt, where you have salt fortified with iron and iodine, has had a big uptake. So now with some partners, Levente has been able to scale up this salt, and it's currently being distributed to more than 24 million people in India. So and able to alleviate issues related to low iron. So a wide range of types of projects going on within CGEN. And some of the newer things that we've been working on at the center are thinking about how engineering can play a role in doing collaborative work together with indigenous communities to address some of the challenges that they've been seeing. A lot of them focused on different infrastructure challenges, from sustainable housing to thinking about supply chain issues experienced by a lot of these remote indigenous communities. And this is an approach that we've been building up within the center, which really relies on collaborative work and a two-eyed seeing approach. So just a couple examples of the type of stuff that we've been doing in the center. And I just want to kind of wrap up, just make sure I give enough time for some questions. I just want to say thanks a lot. It's a pleasure to chat with you today. It's not as fun as being able to do it in person, but it makes it so, at least, it's a chance for us to get together virtually. And I want to say thanks to the people who really do the work. This is a picture. Unfortunately, I was on mat leave the year before kind of COVID hit, so I really haven't had my full group together for a little while. So this is actually just a picture of a part of my group, but really they're the ones that do the heavy lifting, and I'm the one that helps steer the ship. So they're the ones that deserve the majority of the credit, and also all the partners and funders which support the work. So with that, I'm going to pass it back to Marcus, I think, in case there's any questions or thoughts.
Well, Amy, listen, thank you for a great presentation. So I'll remind everybody, to those of you listening, that we would love to get some questions. We've got about 15 minutes, and Amy is happy to answer them. If you can just type them into the Q&A box that's at the bottom of the screen. And you know what? While you do that, I'm going to ask Amy a first question. a lot of this work that you do is inspirational, I think. I bet it's inspirational for students. Do you want to speak briefly about kind of what the students, your undergrad students, your grad students get out of work like this, the extent to which they're excited to do it, and what maybe they do with the experiences that you provide them?
Yeah, I think so. I think this type of work is something which changes the perspective of a lot of students that I get a chance to work with. We started some of the undergraduate capstone projects probably about 5 years ago or so, and a lot of those students will, they're very eager to take part in the first case, and then after they're done, they said this has probably been like one of the most influential experiences they had during their entire undergraduate education. Part of the challenge is that, I think there is a need for a lot of engineers working in this space, but the job market is not as fluid for a lot of those engineers to really step into that kind of role. So a lot of them will go and tend to work off in some industry. But a lot of the first crop of students that I just had actually in the past couple of years have come back to me saying they're not really satisfied with the status quo. And now some of them have gone back to grad school. Others have like moved over industries to places where they felt they could have more of a social impact. So I think it really has, in my experience, it's really driven a lot of those undergraduate students to try to think about how their work can have that more of that social impact. I've had a couple of them come back and join me in my research group also just in the past couple of years. And some of my grad students as well, really when they're going out and joining the workforce, again, they're not really satisfied really with the status quo. So some of my more recent people that have left my group, one is now working at the, one of the students is now working at the Ontario First Nations Technical Services Corporation. So thinking about how they can, bring sustainable energy to many of the more remote First Nations communities in Ontario. So a lot of them are really thinking about how they can, marry their engineering skills with work where they can make that kind of more of a social impact. Yeah.
There are a couple of questions in the chat. I'll get to those in a second. I just wanted to say that for those listening, that one of the reasons I asked this question, and I don't know that Amy has heard the story, but 3 or 4 or 5 years ago when we were still meeting in person, Amy and I were both at convocation one June, all dressed up in our robes while students were getting their degrees. And I recall sitting at the front and watching as students came forward, and there was when it was time for the mechanical students in particular, there was a train of students who went from either the provost or the president having shaken their hands and walked over to Amy and gave her a hug, because clearly she had affected and impacted some of these students quite a bit. I think it was quite heartwarming to see. So good on you. Okay, so we have the questions are coming in fast and furious now, and so I'll take them on. Why don't we start with this one? Can you say a few words on the Reinvent the Toilet project and the extent to which it might make a difference in the developing world?
Yeah, so I think the Reinvent the Toilet project, it's been a project which has been ongoing, for a while, and they set some really high aspirational targets when Gates defined that project. It was a technology which was meant to be completely off grid, basically be its own like independent chemical processing plant. So it's been a project that has been taken, that's understandably given the high bar that was set, has taken a long time in development. A lot of the times that's kind of the nature of this type of work. So I am in relatively constant kind of contact with Yuling Cheng, who's the leader of that project, and they've been constantly revising and refining kind of how they're thinking about the project and how things are being taken forward. I know that right now they're actually talking and working with some commercialization partners. So they've done some, it started out from something in the lab, something that they're doing demos. A couple of years ago, they took it and they started doing some field trials with partners in India. And they're one of the few groups who've actually continued funding through Gates throughout this process. So Gates started off with, I think, something like 20 different research partners on it. And I think, now it's boiled down to around 5 or 6. And they're one of the ones that are still being funded through Gates. And now they're at the process right now where they're transitioning it off to commercial partners to be able to actually make that transition. I think, it has a lot of potential. I think there's still a lot of barriers at place, especially for some of the more remote communities for implementation of this type of technology. So I think it definitely has a place and will make an impact in sanitation. for some of the very, very low income users and some of the constraints at place, I think there's still a lot of barriers at place which need to be addressed to be able to think about some sustainable sanitation in that arena. But they've come a really long way, and it now is at the point where it's going to be able to. And I think they're working towards some bigger implementation in India. And I haven't talked to Yuling in detail about it probably since maybe February of last year. But yeah.
Great. So we have a couple of questions from Paul Collier. I'll just kind of present them both. So one is, have you approached the Rotary clubs for partnership? Many initiatives underway. And then he asks a much more specific question. What energy source are you using to generate the pressure for the drip irrigation system? Yeah,
cool. Yeah, so so for Rotary, so we have, in some of the context of some of the capstone stuff that we've been doing, there has been some discussion with some of the Rotary clubs. I haven't, it's a really good point, and it's something that I've been meaning to follow up on some more. So, I haven't been in discussion with them much in the past couple of years, but you're right, that's a great place to think about partnerships. So thanks a lot for flagging that, and I'll put it back on the radar. And then, so for the drip irrigation system, so for the pressure that we're using to drive the opening and closing of the valve, that's all purely passive. So that's all just from the fact that when you have water in the soil, it's able to exert this pressure. For the feed pressure for the water going into the system, so it comes from the fact that it depends on the implementation. So the partners, depending on who they're working with to set up the drip irrigation system, sometimes it'll be a solar pump, which pumps the water up into the elevated water tank, and it's an elevated water tank that then flows out into the field. Some of the farmers will also use a very simple diesel powered pump. So it all depends a little bit on terms of who's implementing it, in terms of where the energy comes for the initial kind of pressure in the water, which is in that elevated water tank driving out into the drip irrigation system.
All right, great. I'm going to combine 2 or 3 questions here that people have asked. They're coming in quite a few of them. So a number of people are asking about both resistance to new technology in the in the third world, I suppose, and as well related to that, I suppose, is the question of expertise locally to maintain and operate this equipment once you leave it there. And I don't know whether you have a comment on how well or not that's done.
Yeah, so I think it needs to be, both of those things need to be thought of even when you're thinking about starting a project. I think when we're working on projects ourselves, usually what we're doing is we're partnering up with an established partner working in the field, typically as like our starting point. So usually those partners will have long-standing relationships with the end communities, which with which they work, and all the NGOs that we're working with are people that have been working with those communities typically for 10 years, sometimes more. So as a result of that, there's usually a lot of trust that's been built up between, there's a lot of trust that's mutual trust that's been built up between those NGOs and the end users. So I think that's really an essential part for the types of projects that we're doing in the first place. And as a result of, some of that trust, there's not as much thoughts in terms of resistance towards technology. And usually as well, when we're actually looking at potentially demonstrating or trying out a new technology, there's often some of the farmers or whoever it is would be we go through a process where you recruit people to participate, and that recruitment process goes through ethics approval, so really it's a voluntary process, and it's usually there's a lot of farmers, because they've had long-standing kind of relationships with these NGOs and they've had success from different initiatives. There's a lot of them usually, most of them are actually very eager in terms of participating because they've seen previous benefits, and because they have that long-standing relationship with the NGO partners. So it's something that needs to be thought of, and I think it's in the design of how you go about it. It's a critical thing to think about. And I'm trying to remember the second part of the maintainability. Is that right, Marcus? Was that the other? Yeah, so yeah, that's definitely a critical aspect. And I think when we're also going through, on the technology development part, that's part of like when we're, talking about the design process, thinking about, thinking about setting out the requirements, that's part of it that goes through in the first place in terms of thinking about what the details behind that maintainability is going to be. I think it's been a critical thing that's been left out a lot in many global development projects in the past. I talked about at the beginning of the talk how there's 60,000 hand pumps installed in Africa each year, and by the end of the year, about 60% of them are in disrepair. And most of that is because there's not really the model behind sustainability thought about, and like the maintainability isn't thought about. So it is definitely something that's critical. It needs to be thought about throughout the process, and then also just in the infrastructure and setup behind how a technology is going to be implemented.
That's great. I'm looking at my watch. I'll take another question, or maybe another question, and then I will say to those of you still listening that in a minute we'll invite you to hop off Zoom and go into another piece of software that will allow us to kind of network a little. So maybe a last question, Clarissa Brock, just about the advice you would give young professionals, students who want to get into this. You spoke of this a little bit, but students who want to get into the development arena, I suppose, as engineers, advice for how they get the experience in developing countries that will allow them to build a career in this noble field.
Yeah, so I think there are opportunities. There are different internships that you can keep your eyes open for, where you actually get a chance to actually do field work with different organizations. So I know EWB has some opportunities for students to do this type of field work, and as well as a few others. Within CGEN, what we've actually been doing, if you're an undergraduate student and you're interested in engaging in this in more detail, we've actually been working towards setting up summer internship programs also for some students. So we did our first one this past summer, and we're working on increasing some of the availability for students as well. So we did one this summer. So I mentioned about how the American Society for Mechanical Engineering, they have a whole stream which is geared towards engineering for global development. So we had a student that was a fellow working with ASME, thinking about engineering for global development, and working with them this past summer. But yeah, we're hoping to increase some of those internship opportunities as we go forward. So yeah, there are places there. I think it's still, I think all the NGOs that we talk to all see the need for this, but as a career path, the pathways are still opening up. So there are opportunities as a student. What I would recommend is try to be proactive, and there are opportunities you can look at. You're not going to get the top dollar as like a summer internship, but it's going to be, from an experience standpoint, probably something which would change your perspective. And I noticed, and I just want to highlight this because I think we're going to go over to some networking in a minute. And I see Ahmed just joined us, on the backstage of this webinar. So Ahmed, and if you want to just like pop up and say hi, you might have to comment about this too, because you've been one of the ones. So Ahmed works with us as the program coordinator within the Center for Global Engineering, and he's been the one who's been setting up a lot of these internship opportunities. And if you're interested in chatting more about this, go over to Gather Town afterwards, and Ahmed might be able to say hi. So maybe Ahmed, if you just want to pop up, and if you want to add anything that I missed talking about that.
Sure, thanks, Amy. My internet is very poor right now, so I'll keep my video off just to minimize the risk of dropping out. Now that was a very good overview, Amy, and at CGEN we're very ambitious, and we're always looking for ways to engage both faculty and students, and looking especially towards next year with respect to the CGEN fellowship. There's a lot of opportunities that we've been looking into, opportunities with a hospital in Tanzania, which we were, we're thinking of recruiting students to work on specific projects there, opportunities in Rwanda. So, we've spent a lot of time building a pretty vast network of people who really want to work with us. A lot of our partners, they're excited to work with us. So it's just a matter of working in those opportunities. So keep an eye on our website. We're going to keep it updated going forward. We have 2 positions right now that we're recruiting for, one for a postdoc and one for a research associate. So if you or somebody you know is a good fit for either one, please feel free to take a look and refer them or apply yourself. And if you have any questions or any advice or input to us, please feel free to email me, and I'll be at the networking event hopefully.